Hello and welcome everyone. My name is Vaibhav Roy. In this video we are going to study bonding in solids. The topics we are going to cover in this video are ionic bonding, covalent bonding, metallic bonding, hydrogen bonding, van der Waals bonds and cohesive energy. Let's get started. The matter can be classified into four states. They are solids, liquids, gases and plasma states. In this chapter we are going to study about the solid states and bonding in solids. Atoms in solids are held together by interatomic forces. These forces which bind atoms are called bonds. Bonds are of attractive forces and repulsive forces. The bonding energy depends on the type of bonding. Depending on the strength and directionality, bonds are classified into two types. They are primary bonds and secondary bonds. By the virtue of nature, primary bonds are interatomic bonds and secondary bonds are intermolecular bonds. Bond energies of the primary bonds are in the range of 0.1 to 10 electron volts, and the range of bond energies of secondary bonds are 0.1 to 0.5 electron volts. The primary bonds are of three types. They are ionic bonds, covalent bonds, metallic bonds. They are also known as unsaturated covalent bonds. The secondary bonds can be classified into two types. They are van der Waals bonds and hydrogen bonds. Now let's study about the ionic bonds. Bond formed by the transfer of electron between two atoms is called ionic bond. This bond occurs between electropositive and electronegative atoms. This bond is found in NaCl, KCl, KOH, etc. For example, NaCl. The transfer of an electron from the sodium atom to the chlorine atom result in the formation of ionic bonding between NaCl, thus resulting in the formation of Na plus ions and Cl minus ions. Now let's study about covalent bonding. Bonds formed by sharing of electrons between two or more similar or dissimilar atoms is called covalent bond. This bond is possible whenever such sharing result is in decreasing of potential energy. This bond is present in hydrogen, nitrogen, diamond, tin, etc. Metallic bond. The bond which result in the formation of sharing of variable number of electrons by variable number of atoms is called metallic bond. This bond is present in metals. This can be considered as unsaturated covalent bond. This bond is found in sodium, copper, gold, aluminium, silver, etc. Now let's study about the secondary bonds. In secondary bonds we have van der Waals bonds and hydrogen bonds. The van der Waals bonds. This bond has weak bonding force that result in the mutual interaction between molecules or atoms. This weak forces is due to the unsymmetrical electrical charges in electrically neutral atoms or molecules. This interactive force is very small and the bond energies of van der Waals forces are very small. Now coming to the hydrogen bond. This bond is a special type of dipole bond which forms partial positive and partial negative charges. Each bonding molecule have one end as a hydrogen atom converted into the positive ion by strongly electronegative adjacent atom in the same molecule. This bond is found in water molecules. In water, the positively charged hydrogen end of one water molecule is attracted to the negatively charged oxygen end of the another molecule, resulting in hydrogen bonding. Now let's study the differences between the ionic bond, covalent bond and metallic bond. In ionic bond, bonding is by electron transfer and attractive forces are electrostatic forces. Examples of ionic bond are NaCl. In covalent bond, bonding is by sharing of valence pair electrons. Examples are diamond. In metallic bond, bonding is by interaction of positive ions and electron cloud or electron gas. Example of metallic bonds are metals. In ionic bond, bond strength is highest. In covalent bond, bond strength is higher. In metallic bond, bond strength is moderate. In ionic bond, melting points and boiling points are high. In covalent bond, melting points and boiling points are high. But in metallic bond, melting points and boiling points are low. Ionic bonds are bad conductors of heat and electricity. In covalent bond, electrical and thermal conductivities cannot be specified as the variation is from bad to lesser than good. Metallic bonds are good conductors of heat and electricity. Ionic bonds, they are transparent and wide range of wave frequency. The bond is non-directional. In covalent bond, transparent to longer wavelength and opaque to shorter wavelength, bond is highly directional. In metallic bond, transparent only to middle ultraviolet range of wavelength, bond is non-directional. In the next video, we will be studying about the cohesive energy. For all my videos, please visit my YouTube channel, which is www.youtube.com/Vaibhav Roy. If you have any queries, comments and suggestions, please email me to vaibhavroy@engineer.com. Thanks for watching.